Hello, and welcome. Today we're diving into a critical aspect of modern software engineering, building robust monitoring and alerting systems for applications deployed across multiple geographic regions. Think of it like a global air traffic control system, but for your software. It needs real-time visibility, intelligent problem-solving, and instant response capabilities. By the end of this lesson, you won't just understand the concepts, you'll have a clear path to implementing them. You'll learn how to effectively gather and aggregate metrics from diverse locations, and, crucially, how to prevent being overwhelmed by a flood of alerts. We'll also explore how to create insightful dashboards that provide both a global overview and the ability to drill down into specific regional performance. Finally, we'll cover how to automate incident detection, ensuring your system can respond intelligently across different geographic boundaries. This knowledge is vital for anyone building scalable, resilient systems in today's distributed world. Let's start by understanding why traditional monitoring often falls short when dealing with multi-region deployments. Imagine a major cloud provider region goes down. If you're running a global service, you don't want 50 different microservices screaming for attention. What you need is an intelligent system that tells you a specific cloud region is experiencing issues, rather than bombarding you with hundreds of individual service failures. The key insight here is that true regional monitoring isn't just about collecting more data. It's about forming intelligent connections between distributed data points to paint a coherent picture of your system's health. Without this, you face several critical issues. Traditional tools struggle with cross-region latency variations, where user experience differs significantly based on geography. A user in Tokyo has different expectations than one in New York. They also fail to properly handle cascading failures, where a problem in one region can trigger a chain reaction across your entire system. This leads directly to alert storms, where a single root cause generates hundreds of notifications, burying your on-call engineers. And finally, time zone complexities make incident response and escalation a nightmare when your global teams are asleep while an issue unfolds. To overcome these challenges, we need a structured approach. Our multi-region monitoring system is built upon a robust four-layer architecture. At the foundation, we have regional collectors. These are instances like Prometheus deployed in each geographic region. Their job is to gather all local metrics: application performance, infrastructure health, database activity, and even CDN performance. They're the eyes and ears on the ground in each location. Next, we have the global aggregator. This central system doesn't just combine metrics, it pulls data from all regional collectors and intelligently analyzes patterns across regions. It identifies performance differences, cross-region impact patterns, and the health of inter-region synchronization. The third layer is the alert engine. This is where the intelligence really shines. Instead of firing an alert for every single problem, it groups related issues, identifies root causes versus mere symptoms, suppresses duplicate notifications, and escalates alerts based on their severity and impact. This is how we prevent alert storms. Finally, we have the dashboard layer. This provides real-time visualizations with crucial geographic context. Your teams can view a global overview of system health, or, with a single click, drill down into the specifics of any particular region. Let's trace the journey of a metric through our system, from its collection to its appearance on a dashboard. This flow ensures we're not just collecting data, but acting on it intelligently. The process begins with local collection. Each region's collectors actively gather metrics every 5 seconds, capturing everything from API response times and error rates to resource usage. This data then moves to cross-region aggregation. The global collector pulls all this information from every region, immediately beginning to identify patterns across your entire distributed system. Next, the intelligent analysis phase kicks in. The alert engine evaluates these patterns. It asks critical questions. Is this issue localized to one region, or is it a global incident? Is this a new problem or is it related to an alert we're already handling? This context is vital. Based on this analysis, we get contextual alerting. Notifications are rich with geographic and service details. Instead of a vague database error, you'll receive a precise US East database replication lag detected affecting 30% of users. This clarity empowers faster, more effective responses. Finally, all this information updates the dashboard in real time, often via WebSocket connections, providing an immediate visual representation of your system's current state. Effective monitoring isn't just about detecting problems, it's about understanding the state of your system. Our architecture defines several critical states to guide our response. We aim for a healthy state where all regions operate normally with low latency and minimal errors. When issues arise, we might enter regional degradation, meaning one region shows declining performance, triggering warning alerts. More serious is cross-region impact, indicating problems affecting multiple regions, suggesting a deeper issue. The most critical is a global incident, where widespread disruption impacts users significantly, demanding an all-hands-on-deck response. After an incident, we move into recovery mode, closely monitoring for stability as systems return to normal. This state machine approach is crucial for preventing alert storms by providing context. For example, if a database in one region fails, we suppress alerts about related API errors in that region, focusing instead on the root cause. In the real world, systems like a major social network process over 100 million metrics per minute. They need to differentiate between normal traffic spikes during events and actual regional degradation or global incidents. The principles we've discussed today are simplified versions of exactly what these large-scale systems use to maintain service for billions of users. So, to recap, we've covered the challenges of multi-region monitoring, a 4-layer architecture to address them, and the intelligent data flow. As a final self-assessment, consider this. How would your current monitoring system handle a complete outage in one of its primary cloud regions without causing an alert storm?